One of the big focus area over the last few years has been the age of the customer applications. These are customer-focused applications, or what we call systems of engagement applications. And that applies, first of all, to every industry, whether it's a retailer, it's a bank, insurance company, healthcare organization, manufacturing companies. And the system of engagement is getting to interact with the customer. A lot of time we speak to customers from these different vertical industries, and they're telling us their current architectures are not up to the level of the requirements for these next generation of applications. You need to have trusted data, not only real time. Real time is good, but you need trusted data. Traditionally, we have built transactional systems separate, operational systems separate, analytical systems separate. But why the separation? Because you want to do analytics at the speed of transactions. So what we've seen as a trend is that we are starting to collapse the stack, where we want to do all of these three layers together, the transactional, the operational, the analytical applications together in the same database. Now, caching is very good if you are doing a lot of read-only access to information. But if you really want current data, well, it's not going to be current data, right? Because it's a layer which is sitting on top. The data is going to be moving from the transactional system into the cache on a regular basis. And so there's always a disconnect between transaction systems and the caching layer. You actually have to deploy a lot of servers together for caching, which increases the cost of deployments. When you look at in-memory databases are an evolution from the caching layer. But they do have limitations. Most in-memory databases are very engineered towards a specific workload. Sometimes they're doing operational only, or they're doing transactional only, or analytical platforms only, not really hybrid applications in that regards. Now, the evolution beyond these two is the hybrid memory architecture, which is the evolution beyond in-memory databases. They can do a lot more data than the DRAM can handle, actually, because you have flash, you have SSD available. It can intelligently place the indexes and the data between these two platforms, with DRAM and SSD, in a very intelligent manner. You can do multiple workloads, whether doing transactional, operational, analytical workloads all together in the same database. I would say hybrid memory architectures are this evolution beyond this in-memory databases, which takes it to the next level. What are the benefits of hybrid memory architectures? The first important thing is it's about trusted data. The data is available to use for any type of purposes. We are building these new types of applications or doing a real-time assessment. That data is available to you. We have heard customers telling us reliability as being an important factor in success. In fact, organizations who have been using older technologies and architectures for in-memory have struggled with reliability of data. The benefit also for hybrid memory architecture is the cost. It's more economical. The customers have told us that they can reduce the number of servers. Hybrid memory architectures don't need that duplication of data, number one. So you kind of collapse together. In fact, we've seen customers telling us that you can actually do a high volume, high transactional systems with just a couple of servers with hybrid memory architectures, compared to maybe reading 100 or 200 servers with caching. The benefits of the hybrid memory architectures span across various vertical industries. So I think every organizations have seen a benefit, and we feel that the hybrid memory architectures are a good fit for organizations to leverage for these new generation of applications in question.